All right. So welcome to our July Miami JS Speedup. I'm Christina. I'm one of the co-organizers. Um, Today we're going to be talking about front-end frameworks, back-end databases, and GraphQL. And our speaker is going to be Gavin. He's a technical evangelist for Hasura, and he's been working in startups and developer communities for about 5 years. He's a polyglot developer, and he's been coding since he was 9. So I'm going to go ahead and let you take it away, Gavin.
Yeah, absolutely. I also incidentally happen to live in Miami. I'm over in West Kendall, so I presume a lot of us are neighbors. It's nice to meet you. And yeah, the presentation that I kind of have prepared for us today is going to be more of like a practical application. So we'll cover the background of GraphQL and the concepts, but I really was hoping to look at it more from like giving you the skills that you could take away from this to where you feel like you can be productive with it, which I hope is exciting. So we'll see. Yeah, let me go ahead and share my screen. Okay. So you all can see, I assume?
Yes, we can.
Okay, sweet. Yeah, so we'll cover this a little bit dry conceptually, but it's important just so that everybody can, who may or may not have touched GraphQL, can kind of follow what's going on. And then after we cover this, we'll go into how you as a developer can use this, and we'll show some hands-on examples using, typical technologies that you're probably already familiar with. So what is GraphQL? It's a specification for how you design open API for APIs. It's similar to things like Open API or Swagger, if you've ever used that. One of the big misconceptions about GraphQL is that it's a specific library or framework, which it isn't. Those are all implementations of the specification. It's just a way for you to define a contract about what your data types look like and the methods your API exposes. If any of you guys have worked with gRPC before, this is really similar. So what it looks like is basically like this. So a really basic example would be modeling, hey, we have a type called user that has these fields, and we have these queries, which are operations that you can perform on your data. Queries read data and mutations change data. And so we have users, and that returns a list of users or a user by ID, which takes an ID and returns a single user. And then you can kind of extrapolate that for the mutations, which is the same thing, kind of update and delete your basic CRUD stuff. So in summary, GraphQL is a way for APIs to define what the resources they have available are. So things like a user, and how you can interact with them. So can I create a user, update a user, etc. And they do this in a discoverable way, which is super important. And we will circle back to this in a second. But this discoverability and kind of being able to introspect them as an outsider and find out all of the things they have available is in large part what powers the GraphQL experience. So from a little bit more practical overview, writing GraphQL APIs isn't all that different from writing the traditional sort of APIs that you might be familiar with. So I'm going to make a wild assumption that if you are attending, you maybe have written an Express.js API at some point in your life, and this code might look familiar to you. So here we're saying we have an operation where we can hit a /users endpoint. And what that's going to do is we just want to get all users in our database and return that as JSON. And then similarly, we have an operation for getting a specific user where we hit /user/ID, and that's looking up in our database the user where the ID matches the URI param. So if we were to write this in GraphQL, there's not a whole lot of changes. Really, the biggest difference is that we just need to explicitly tell GraphQL about what our types are, what resources we have available. So from an entity perspective, we again might have something like a user with an ID and an email. And then we need to tell it the actions that it can do on this entity, which in this scenario would be like our get all users would just be this users operation that returns a list of users, and then users by ID would be this one here that takes an ID. And the way that this works in GraphQL, instead of having endpoints like these, is you have what are called resolvers. And there are two types of resolvers. We'll see that in a second. But at the top level, the ones that you're going to be calling from your application or client are usually going to be query or mutation resolvers. So when we're querying for data, we have this object of resolvers, and one is users. So we're saying when you query for the users field, the data that you want is the result of querying the DB for all users. And the same thing when our GraphQL API gets queried for user by ID, the information that we want to send back in that response is the result of querying our database for the users where the ID matches the args that were given. So it's really not that dissimilar, again, to writing your traditional Express REST type APIs. So you might be thinking, I don't really get it, or why bother? What's the point? It seems like a lot to learn. I already know how to write REST APIs, et cetera, et cetera. These are all super valid points. So there are a couple of reasons why GraphQL is a technology that's worth investing in. And most of it has to do with you as a developer being able to be a little bit lazier and to make the experience better for everybody. So one is that it has really broad ecosystem of tools that make it so that you can sort of automate the majority of work involved in building these apps. And that's front to back and everything between. And what I mean by that is that you can sort of start from a data model, like, hey, create a user in the database. And then all of the code that you would need to write for the backend API to access that resource, from a front-end client to talk to the backend API, you can basically just auto-generate all of that boilerplate and do it in a type-safe and fully documented way, so that the only thing you as a developer have to think about is things like custom business logic. And kind of as an ancillary to that is that it allows you to develop your database or data models as your core guiding principle. And the rest of your app kind of follows from that, which that prevents a whole host of issues that arise from trying to keep product development in sync with your data model or other things that arise from schema changes or refactors. So if you don't have your database models and your schema kind of in sync with the way that you do your client and product development, that kind of lag can cause a lot of issues, especially when you do larger refactors. And again, one of the greatest benefits is that you can auto-generate these type-safe SDKs, not just for JavaScript or TypeScript, but for various language for interacting with your GraphQL services. And these act both as a source of documentation and sort of type-safe contracts. And it makes it so that you don't have to get out of the flow when you're developing and go look up the API documentation. All of that information is there for you right there in your IDE. You just hit the autocomplete and it'll show you what methods are available and what types they expect. So that was a super rapid fire and kind of topical overview. We'll circle back down to these bottom parts. But the next bit that we were going to look at was, okay, how do I actually use this? And right now I'll pause just to see if there are any questions before we move on to actually like building and consuming GraphQL.
No questions just yet.
Okay, sweet. Okay, so with that in mind, the application that I've kind of brought and prepared for you folks today to share is we have a Next.js app, which is fairly popular. You may be familiar with it. But let me show an overview of what the app does, and then we can kind of talk through how it was built and talk through the GraphQL stuff. So it has a blank landing page. This is irrelevant, but you go to a user's page, And we're given a list of users, which we can either view or delete. And if we click on view, then we're taken to a user specific page with the ability to update this user information, and they have to-dos. So I'm sure you're very surprised. It's yet another to-do app, but we're going to look at it from the point of building it front end to back end. And this is the database that we have hooked up. This is the company I work for, Hasera. And Hasera kind of fills in the gaps for being able to just say, create a database table, like here's some table, and put these columns on it. I want, created at, and an ID and a name. And what comes out the other side is a GraphQL API. So we'll kind of circle back around to this in a second, but that's the high level overview of what we're going to look at. So before we do that, I thought it might be probably useful to explain when you interact with this GraphQL API, what's going on, because it probably wouldn't make a lot of sense for me to click buttons on that page and then GraphQL API pops out and you're kind of left trying to fill in the gaps. So I have this, which we're gonna work through really quick. And what this is it's pretty cool. It's we're just gonna build a GraphQL service that doesn't run on a server. So we're just going to make an executable schema that doesn't have a web part. And that means that you can query it locally as if it were just like a regular JavaScript variable. And the way that this works, what's happening behind the scenes is that we have some kind of type definitions for our GraphQL, which here we have defined author and a post. And so author has a list of posts, a post has a single author, and then we have these queries and mutations. So the queries that we're going to write are get a list of posts and get an author by ID. And I'm going to delete this because we don't actually need that. That was for syntax highlighting. And this is the bit that we're going to focus on for this purposes, because once you understand resolvers, then the rest of GraphQL just kind of falls into place. And so to try to explain this, the way that it works is if you query GraphQL and you're a GraphQL server, and you get a query like this, this is saying, I want posts. And on the posts object, I want ID and title. And then I also want a list of all the authors on the posts that are related somehow, which we'll talk about how that works in a second. But I want all the posts, I want the post's author, and I want the author's ID and first name. So what GraphQL does is it takes requests like these for either fetching or updating data, and it translates them into operations. And the way that those are mapped is, like we saw before, is in resolvers. And so this is a little bit in the weeds, but it's important. The spec defines 4 arguments for resolvers. So you get a parent, which is the previous object on a field. We can ignore this. You don't often use it. The second argument is the args. So for example, when we do, we have upvote posts and author that takes an ID. And these resolvers, these arguments will come in that args object. The third value that we have is context. And this holds things like session information that you want to store on your server or a database connection, basically stateful info. And then info, this is the one that you will almost absolutely never use unless you're writing schema transformations, but this just holds field-specific information about the current query. So that's how you read these resolvers, so they don't just look like random lambdas. So this posts, this doesn't take any arguments, so it doesn't have any argument values here. And it's always just going to return this static array of posts. And then authors, we have an empty context value. we ignore it. And then inside of args, we're going to be passed the ID. So this is args.id. And it's going to say, find every author where the ID matches. We'll ignore mutations. And then the second part that you need to look at is, okay, how does GraphQL know how to attach these child fields? So if we query the author of a post, how does it know how to attach those and to return the right records when we're doing these nested queries? And that is because of field level resolvers. And so in this scenario, and it almost always looks like this, you have an author type, and you're saying, when I get asked for the posts of an author, the value that you should give me back is the result of posts filtered where the post's author ID is the same as this parent author ID. And almost always your field level resolvers for relationships are going to work like this because with relational data, you usually join on IDs. And then you just have the opposite for post and author, which is saying, if I have a post and I get asks for the author, then give me the authors where the ID matches the post's author ID. And so that's how this nested, that's the basics of how this sort of nested resolving works. There's no magic. It's all very manual. And so to show you how this works, we'll run Quokka on this file, which is super cool. What it allows us to do is to basically do a live evaluation of every line in the editor. And what you'll see here is that lines which have been called during the execution flow, these turn green. And we can hover over lines that return values. So for example, results, and it will give us the data. So here we have data, author, ID, blah, 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 but we'll come back to this in a second. The reason why Quokka is super useful here to sort of show live execution is because I'm going to show you what happens when I run the query author where ID is 2, and I ask for the ID, the first name, and then the posts. So if we look at the execution flow, we see resolvers being hit. We see the top level author being hit, but posts is white. This line is never called. And then we see the author field's post resolver for when it tries to resolve this nested post. This turns green. And if we wait a second, we could probably get this to actually show the ID, which would be 222. But that's irrelevant. I'll just do, let's just stop and start. Yeah, there you go. So when this line is called, it's called with the values 2, 2, 2, 2. So every time it's called with 2. And the reason being is because that author ID that it's trying to resolve is 2. So that's the execution flow, is that it's resolving author here, and then it needs to resolve post from author, and that author ID is 2. So every time it tries to resolve a post, it's always looking for where the author ID is 2. Then if we look at results, then you can see, okay, the data we get back from executing that query is we get author with ID 2, first name, blah, 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 and then we get all these posts. And if we look at these posts, then I can show you. Results.data. Okay. Anyways, the point that I was trying to show you was that all of the posts would have author IDs that were 2. But yeah, this is essentially how GraphQL works at a super basic level. And this is what happens when you're querying a GraphQL server. This is how you can write your own GraphQL server. And then from here, the next part that we would kind of transition to is showing you how to interact with a GraphQL server that has these sorts of resolvers written and consume it on a front end React app using auto-generated type-safe tools. So there might be questions. I feel like this is a good time to ask whether or not there are questions about this part.
So Amarin asked if GraphQL can be used for different like HTTP methods like post, put, and update. So I did answer that, but you can go ahead and elaborate.
Yeah, the question being, is that a question of like, if you have a GraphQL resolver, right? Like, let's say we have this upvote post, could you use like an HTTP post to another API or like a GET request where we're doing like, you know, fetch some API where the method is like post?
I think more like can you I suppose the question is, and they can elaborate or they could correct me if I'm wrong, but I think what they want to know is, you know, can they do like, for example, puts so that they could update data, or could they, you know, delete a record or something like that.
Oh, okay, I see. Is GraphQL good for fetching data or it could be used as well for post, but got it. Okay, yeah, so I see, yeah. Got it. Okay. Yeah, so they're right. GraphQL basically, you know, like Christine had said, is it condenses the HTTP verbs like get, post, put, patch, delete. Those get condensed into just either a mutation or a query. So instead of having HTTP verbs that define your option, you always send a post request to GraphQL, but then internally you tell it, we could be like fetching, you know, users, we could be creating new users, we could be deleting users, it could be like a weekly sales report. You can basically run any arbitrary logic, and there's no, nothing bad would happen if you put create user as a query. You could create or delete users as queries. It's just also not technically correct. But the rule is that like if you're fetching data in GraphQL, you call it a query. And if you're inserting, updating, or deleting data, you call it a mutation because it mutates data.
Cool, thank you.
Yeah. Yeah. GraphQL works for all CRUD. Yeah. Yeah, exactly. Okay, sweet. Yeah. So that's basically how this works. You can take that out there, and then the result would be different. Now it's just data with author, no posts. So it's really nice. It's super ergonomic. You basically fetch data with JSON looking objects that are in the same shape as you want the return data. But yeah, let's stop this.
Hey Gavin,
And
can you go over like Quokka and stuff, and you know the tools that you're using here?
yeah, absolutely. So basically the tool that you're seeing is this Quokka or Quokka JS. I'm not really sure. But basically what it lets you do is it's sort of like a live REPL. And so you start it on your file and it'll show you a live output of every single line. And it's really great for prototyping. Because you can just like really rapidly develop stuff and you get immediate feedback. So there's no like change the file and then run it. So I think it's like $50 a year if you want the pro, which is super worth it in the time that it saves you. But yeah, that's what I was using to kind of show that that execution result and the live output of querying, which I just don't think would have been very intuitive if you couldn't see like which lines were being hit and in what order.
Cool, thank you.
Yeah. Okay. And so now let's come to the actual, how do I use this part? So the example that you saw was with kind of an pre-prepared to-do and user model. Just to maybe explain how this works. This is Hasura. It's free and open source. We do have a paid cloud product if you want to deploy it and have it managed for you. But if you want to just run it yourself, what I'm doing here is I'm just running our open source version in Docker Compose. We have a get started file. So you just clone this file and then you run Docker Compose up and it starts. We have a Postgres SQL database and we have Hasura running that's connected to those two. So I won't do the whole feature set of Hasura and what it allows you to do, but we saw when you're writing GraphQL, you need to write these resolvers for CRUD, and you would typically hook that up to like your database driver, whether that's like connects or type-orm, or in other languages, you might have like, Ruby on Rails, et cetera, et cetera. The point of Hasura is that you see we have this user table, which has an email, password, and ID. The way it works in that Hasura is that you can have you create a resource and it lets you immediately perform CRUD operations on those resources. So it auto-generates a CRUD API. It has built-in configuration for things like authorization. You bring your own authentication, et cetera, et cetera. So yeah, we can query, we can mutate. It comes with full CRUD, aggregation, statistics API, and you basically click a button and it's created in your database, works with migrations, yada, yada. I won't do the whole spiel. But for the purposes of kind of showing how this works is, let's say that we want to create a new table in a PostgreSQL database. We want to give it an ID, so we'll give it a primary key. We want like created at, updated at, and this can just be whatever type text. So this would be kind of step one of data modeling, is that you are sketching out your data models in your relationships. Let's also put a user ID on this just to kind of show what that looks like when you have relational data. So we'll say that a user kind of has one new table entry that's less confusing. And the way that that works is we click add a foreign key here. Forgive me if you're not familiar with like relational data modeling. I'm going to make some assumptions just for the sake of time. But basically, we just say that on this table, our user ID is a field that is a reference to the user.id table. And so that's how these are getting linked together through like a parent-child relationship. So we'll add that table. Fetch metadata. Okay. Okay, so it already exists. Create table entry failed. Track new table entry. Okay, sweet. And so then what happens is that now we have this new table. And if we go into our API, we can start now querying it. We can insert it. So if we do insert new table entry here, then we'll put an object, we'll put a user ID. This user ID will be 1 and whatever will be ASD. And what we're going to do is we're going to select ID and create it at. Oh, this user ID actually needs to be 2. There is no user ID with 1. Okay, so now what happens is this has been auto-generated. This is our GraphQL Resolver. And if we go into new table entry and we browse rows, we can see that that's been created there. But there's actually no relationship between this new table entry and user. So if I try to query this and I do new table entry, I can't drill down like we did between posts and authors. I have a user ID, but there's no actual user. I can't get to the nested fields. So the way that you do that is you go here, you go to relationships, and it will actually just suggest adding that based on the fact that the foreign key exists in the database. And so we're going to say add an object relationship, which is a one-to-one on user, and we'll call it user, which it will auto suggest. And then we need to do the opposite if we want to be able to go the other way, which is to query from user to new table entry. We go to relationships, and you'll see that it's suggested here that we add these. So we click new table entries, we save it, then we go back to our API, and you'll notice that now here in this dropdown, we're able to query all of the fields on user. So we can get an ID and email, and then on users, let's get their to-dos. I want the to-do ID, I want to-do is completed, and I want the to-do description. So now if I query that, you can see here's this new table entry. Here's the user it belongs to, user@example.com, and here's their to-dos, present at Miami.js. So that was all just generated without us having to write any code, which is pretty sweet. And it's really powerful if you model your applications database first or data model first like this, because you can sort of sit back and see how your data models fit together and what the right relationships and columns look like. And then once you do that, you can just automate all the boring stuff, generate the CRUD. And then I'll show you the next part, which is how we can auto-generate kind of code to consume this on the front end. But yeah, are there any questions here before I move on to the last part?
So yeah, there's one question, which is when's a good time to use GraphQL over REST API or vice versa? If there's any guidelines or if one just replaces the other.
Gotcha. Yeah, it really depends. You know, I really wouldn't say just start writing GraphQL just because it's newer or just because it has benefits. If you have a legacy REST API and you've got to maintain it, that's an initiative that's going to be long running. One of the cool things with GraphQL is that you can actually like merge REST APIs into it. So like, for example, with Hasura, if you have a REST API, you can just merge that endpoint into the GraphQL service and start making relationships back to it. And it's the same thing with remote GraphQL services. So here would be your REST API and here's Hasura. But you could do this with any like GraphQL service as well. I guess, you know, my answer is like, it depends on whether you think the outcome of switching to GraphQL in terms of like developer productivity is going to outweigh any sort of like refactoring costs you have on, you know, how invested you are in your application.
All right, thank you.
Yeah, absolutely. Okay. So kind of last closing piece here. So if we have this, you know, backend generated for us, we have this CRUD taken care of, we have a database, our SQL data models, all the relationships set up, then the next thing we need to do is actually consume that. And so there are a couple of tools that you can use here. The one that I'm going to show you is called GraphQL Zeus. This is one that we use on some projects at Hasera. We have a HaseraCon talk about it. And what it does is it lets you give it the URL to a GraphQL schema, and it basically spits out a fully type-safe GraphQL SDK with TypeScript types that you can use. And the way that it works is that in your package.json, you have a script, or you can run this through Bash, but we're just going to send an introspection request saying, hey, tell us about every data type and operation in your API to our GraphQL service. And this tool can use that to generate its kit. So if I run yarn generate GQL client, then it's going to run that, and it'll spit it out to utils.generated that I've specified here, and it's done. So if we look in utils.generated, then what we get is this huge file, right? And I'm just going to go to something like this. So what this is this is code that you would never interact with yourself, but it allows you to do some pretty neat things. And this basically contains type definitions for every single type in TypeScript automatically that the API exposes, and ways to map them from inputs. It comes with by default with a client that you can use. But I'm going to show you how you can integrate it with Apollo client and their React hooks. And so, yeah, let's see what that looks like. So to wrap this, what I've done is I've taken these sort of generated query types for a database, and also just to prove that this is that database that we just created. What did I call that weird table? New table entry. Just to prove this is that, here you go. So new table entry has all these operations. It has 595 entries in this. So this has all been generated from our data model and GraphQL schema definition. So this was just done on the fly. Then what we have to do is we got to write a little bit of boilerplate, but you can make this work with any GraphQL tool that you choose, even if it isn't a GraphQL client. So that could be like React Query, it could be like SWR, it could be plain fetch functions. But in this scenario, I've kind of written these TypeScript typings to integrate it with Apollo's React Query hooks. And so the way that you consume this is, we'll go in the app here. You set this up like normal. We don't really have time, I think, today to cover up the basics of like how to configure Apollo and whatever framework it is, but we have Apollo configured here like normal. And in our app, we'll go here. The way that this works is we have these used typed query, used typed mutations hooks now. And so basically the way that these works is when you autocomplete, now you'll get the full list of all the values that every single operation your API takes. So let's say we wanted to select from that new table, then we could do like const blah equals used typed query. And we would say, here's a list of every single query operation that we can perform on our API. That's fully type safe. So we don't need to reference our documentation or our database schema or anything. We just kind of use our editor to help us. And so I want to query this new table entry. And the way that this works is the first set of arguments that come here are your filter clauses. And the second set is the columns that you want. So in our filter clause, we could say something like new table entry, let it autocomplete where, and then it'll show us what we can filter on. So where whatever is equal to, greater than or equal to, I like, not like, blah, 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 where whatever is equal to, you know, Miami.js rocks, okay? And then the field selection, again, just autocomplete. ID, true, I want the ID column. I want this whatever column true, and then let's go nested. So let's grab the nested user, and inside of the nested user, again, we can autocomplete all of these properties that are available in user. Let's grab a user's email, true. And here comes the magic. So if we destructure this and we look at data loading error, if we look at this data object here, you'll see that the data that is returned mirrors only the fields that we've selected. So it's type safe. So it has ID that is a number, whatever, that's a string, and it has a user object with an email that's a string. So you'll notice if I remove ID from the selection set, the return type of data no longer has ID. If I add a field to user, then the selection set now contains that new field in user. So being able to dynamically infer return types from an entire GraphQL service, which may be composed of data from multiple databases, data from multiple REST and multiple GraphQL APIs, and having all of this power at your fingertips is just incredible. And using tooling like this is something that we've seen at Hasura has been a tremendous impact on our developer productivity, and we're just able to kind of, crank out, applications and tooling, and it's really a joy to use as a developer, and you have a lot more safety and security. The next time that if we change something, let's say if we were to delete password from user, this would automatically start failing our type checks. So we know everywhere in our application code that is going to cause problems as soon as we change our schema. But yeah, that's pretty much what I wanted to show you the gist of it. There's more details that I can go into over here that are kind of more advanced things, but maybe now would be a good time for questions on this part too.
Yep. So we have a question. Can you limit the, I guess queries and mutations that are generated via like some kind of config or something like that? Or is it just going to take whatever you've gotten and generate that based on that?
Yeah, so you can limit it. One good example would be basically you have permissions, which if we were to create a new permission here, you could basically deny, and this is Hasura specific, so I'll give the Hasura specific answer and then how you would do this yourself. On Hasura, you have roles which give you access to your CRUD, and then within CRUD, you have column and aggregations. But what you would do is, if you don't have permissions, you can't see the actual field inside the API at all. And so when you generate the API, you would use it using a token or a role that doesn't have the permissions to see the tables or the operations that you wanted to omit. If you were going to do this in your own GraphQL server, something like Apollo or like an Express.js and GraphQL JS implementation, you would just need a way to implement field hiding from introspection yourself, which is also possible.
Okay, thanks.
Yeah. Is Hasura running Node.js to connect to the DB? Hasura runs on a language called Haskell. The code is open source, so if you go here, everything that's related to the server, the part that handles the basically the GraphQL API and what you don't see under the hood, all that code is here in the server, and this is going to be all Haskell code. The web console that you see us interacting with, all that code is here under console. This is React and a mixture of TypeScript and JavaScript. Our CLI is in Golang. And then we have some like miscellaneous tooling and Python and maybe a couple like various languages. But yeah, all of this is free and open source. So feel free to poke around whatever code you want or fork it and make changes. We super love PRs. If you want to add functionality, we recently made it really easy for folks to add support for new databases. So if you happen to know Haskell and you want to add a database that Hasura doesn't support yet, we support MySQL, Postgres, MS SQL / SQL Server, BigQuery, Yugabyte, Citus. But if you wanted one that we don't support, you can basically implement this type class in Haskell, which is like an interface, and then it should work. And we'll happily take that PR and stuff. Okay. can you limit the methods, for example? Got it. Yeah, so there are a couple of other things. We have a few more minutes. A lot of the benefit of GraphQL comes from the ecosystem. So like you saw that TypeSafe SDK. There's a tool called GraphDoc, which is really great. So it basically lets you run one command and it generates a static doc site from your entire API. So this is Shopify's GraphQL API. And so then you could search here and look at, okay, create, check out create payload. And you can see here, we can search checkout and, see everything here. There are tools for basically like automatically testing your GraphQL API from like load testing. So there's like Easy GraphQL. This has both basically a load tester that will introspect your API and like automatically test all operations. Just do like a request per second test. And then it has some nice like mocking and just general software testing tools. But yeah, the ecosystem for GraphQL is really solid. And in my opinion is what makes it, really stand out. So yeah, I think that pretty much covers the majority of what I wanted to show today. If there are no more questions, we can just kind of have a conversation. But yeah.
Cool. Yeah, I don't know if anyone wants to unmute themselves, and I will allow that again. If anyone wants to unmute themselves and ask any questions, make any comments, feel free to do that.
Thanks. I appreciate it. Yeah, I hope it was interesting. I tried to make it practical, so it wasn't just like a bunch of slides and you get like theory and you're like, okay, well, I'm not sure I came away from that with anything. Sweet.
Yeah, GraphQL is being used a lot. GraphQL actually gets used a lot in like DeFi, like decentralized finance, along with React. So it's like a great skill to have if you want to get into something that not a lot of people are doing and kind of have a leg up. And a lot of big companies are using it too, like Shopify and.
Yeah, it's definitely been gaining a ton of popularity. It's not going anywhere. That's for sure, at least for the foreseeable future. About the repo. Yeah, so you all can check it out on Code Sandbox. So this one should have it live. That one just won't be connected to my actual database, but all the parts are there if you're interested. Yeah, Next.js and TypeScript, super solid tech. I'm a huge fan of the stack. I'm a really big Vue fan myself too, but when we build stuff at Hasera, we kind of have to, cater to whatever's like most popular. So that usually winds up being React.
Yeah, I'm a Vue fan as well. I definitely prefer it over React personally.
Yeah.
But it's definitely not the popular choice.
Yeah.
Maybe, maybe you could talk about like how would you, we have like 5 minutes. How would you go about migrating from a REST API to GraphQL?
Got it. Yeah, so basically you can sort of, for lack of a better word, like strangle it. And what I mean by that is you can start by having GraphQL resolvers that are just calling your REST API, right? So like you saw there, we were like filtering on an array. Instead of having resolvers that do that, you can make like an HTTP request to your existing API and then just basically like write the types around it. And then there's two ways that you can do it. So you can either do that, and then eventually start moving the business logic into the GraphQL API instead of just like shooting it off to the existing REST API. The other way that you can do it is to basically keep what you have as a REST API existing and then just adopt GraphQL for things that you're going to build in the future. And there's a lot of tooling. We didn't have time to talk about it, but the reason why GraphQL has like the graph in its name is that it lets you sort of combine data sources from a lot of different places. So it could be like multiple databases, multiple REST APIs, multiple GraphQL APIs, and you can make one gigantic sort of like federated data graph between them. And so it's super possible just to like leave your existing REST API there. And if you're interested, just build what you want to build in the future on GraphQL and bring in all those REST API endpoints to kind of create like one big picture graph. So those are kind of like the two main ways that I've seen people do it.
Cool. Are there any tools for like, well, let me see what questions others have. So you just answered that one. And then can I use GraphQL with other databases? Yeah, are there any limitations to what databases you can use it with, or can you just use it with any one that's available?
Yeah, so GraphQL itself is more of like the spec. And so when you write a GraphQL server, really you're just writing like functions, kind of like an API endpoint, and the functions could do anything. So if you have like a MongoDB database or like an Oracle database, your GraphQL resolvers, they can reach out to those. There's not really a limit on what you can do with it. The tools that I showed you, so Hasura, we basically have auto generation built out for a lot of databases. Oracle and MongoDB are not one of those. Those are ones we're working on in the future, but there's a really cool tool called GraphQL Mesh that does support them, and it can fill in a lot of those gaps. So like the GraphQL Mesh, that's one for MongoDB. And then I feel like they had one for Oracle, maybe they don't, but yeah, you can basically just spin up GraphQL APIs on top of whatever data you have. There's not a limit because it's just like it's just like a function, and so it does basically whatever you want it to.
So we've got another question, and I guess you could compare this to REST. And I know that I work with REST APIs, and it's usually a pain in the butt. But when your data model changes, what's the maintenance like in a GraphQL API?
Yeah, so we have two camps of people. We have like the DTO, like DAO people who like to put a sort of like translation layer between what sits in the database and what gets exposed through the REST API so that it's not as coupled. And then we have the people who like it to be transparent so that the data that is going back and forth is like an exact one-to-one representation of what's in the database. You can do it with either. The way that we've seen people kind of successfully implement that kind of like DTO uncoupled approach is by using versioning. And so it's not necessarily the same thing, but what you can do is basically release a V1 and then you could continue to serve a V1 where if your API evolves, then you just have different fields and different data response shapes being served on a V2 continuously. So you can think of like the versions as almost like data transfer objects, kind of like a weird way.
Okay. And so do you know of any tools that you could like, I don't know, like feed it like REST endpoints and it could like generate like a GraphQL config or whatever?
Yeah, so it's largely dependent on whether you have, they usually have to have like open API or some kind of description of them. But if you do have some format for your REST endpoints,
Like Swagger or something?
right, yeah, GraphQL Mesh can do that too with its open API handler. So you basically just point it at the REST API endpoint, and then you give it the Swagger or the open API schema, and it can convert it into a GraphQL API that it can serve on top of it. And then it allows you like a degree of customization and kind of how you map things, or if you need to like handle like auth and stuff like that. It's pretty cool.
Neat. Okay, cool. Good to know. Any other questions? So I think we're good. Gavin, thank you for being here. Thank you for teaching us about GraphQL.
Yeah, thank you. Thank you all for having me. Yeah, absolutely. If anybody's in the area, hit me up on Twitter. I'm at Gavin Ray Dev. Always down to hang out and nerd out about stuff. So, yeah, thank you.
All right. Thank you guys. Have a great night. See you next month.
Bye.